Let's get started with the first lecture material. Okay, now probably something that didn't come out very clearly when I was talking to you earlier was that the text, Mobile Communication by Josh and Schiller, second edition, I would highly recommend that you get a copy of this book. It's there in the bookshop. I just went to the bookshop this afternoon. There are 30 copies of this book. This book is also available in closed reserve in the library. And there's also a website. This is the website for that book. And some of the slides that I'm using are also available on the website. But obviously, I've taken the Schiller slides, and whenever I go to a conference or when I go to a meeting and I see that there is a very useful slide which I can put into this subject, I take it and put it in. So you see that some of the slides that I've added in this particular lecture are from various sources. Okay. A second reference, the second one I'm not expecting you to buy or something, because this second text is also available in the library. This has some of the problem-solving exercises that we've used in this subject are from the Stallings text. And I'll also try and, whenever I come across good presentations from people in industry, I will add those to this particular, to UTS Online. Okay, now the text has been organized. The organization of the text and the organization of the subject is very much similar. At least there's at least a 70% match between the two. It's always impossible to find a textbook that matches a subject 100%. So we have the introduction chapter, the first chapter, which coincides with what we're going to do today. What we're going to cover next week is going to be based on wireless transmission. What we're going to cover in week 3 is going to be based on media access control and so forth. So let's get started on the lecture 1 material. If you look at any communication systems, a very simple model of any communication systems involves moving information from the source to the destination. And in order to move information from the source to the destination, the information has first got to be prepared or converted into a form that can be transmitted through a transmission systems. So that's essentially the function of the transmitter. And then at the receiver, you've got a unit that performs the opposite of what the transmitter is doing, that is tries to extract the information from the ones and zeros that it receives over the medium. Now, this transmission medium is the focus of this subject a little bit, because in wireless communication, this transmission medium is a wireless transmission medium. Okay, so it is quite different from a wireline based transmission systems. Okay, here's an example of a model. Okay, so if you've got a computer that communicates through a modem, through a PSTN network. The PSTN network in this case corresponds to a transmission system. And at the other end, you have a receiver, which is also another modem, and it might communicate with the end of the information, which might be a server. So essentially, the area that we're going to focus on is a little bit of the transmitter and a little bit of the receiver and a little bit of the transmission system in the context of a wireless network. So when we talk about wireless, we are essentially talking about any communication that takes place using the air as a transmission medium. So in order to transmit signals through the air, we need an antenna that converts signals from an electric signal into an electromagnetic signal so that it can be transmitted over the air. Now, there are different types of wireless systems. Wireless systems can be classified based on the way the signals are propagating. So if you've got one transmitter and you've got one receiver and electromagnetic waves traveling between these. This is referred to as a point-to-point wireless communication system. Okay, because you've got one transmitter and one receiver. Now there are in a point-to-point wireless transmission systems, the antennas that you'll be using will be highly directional, because you've got to transmit as much of your electromagnetic energy in a very confined direction. And we'll talk more about antennas in the second lecture. The second classification of based on propagation is referred to as point-to-multipoint wireless communication. These are communication systems in which you've got one transmitter and a group of receivers that are communicating with it, but not all. The third category of based on classification of wireless systems are referred to as broadcast systems. So you've got one transmitter that is transmitting signals most of the time equally in all directions using some kind of an omnidirectional antenna. So you have things like broadcast, TV, and radio are good examples where signals are transmitted almost equal power in all directions so that you can get maximum coverage. So this is in terms of in terms of propagation, but you can also classify wireless systems in terms of mobility. Now, one of the important things of wireless system, and in more particular mobile wireless systems, is the fact that your receiver is moving. So these are, now the term mobile and the term wireless are quite different. Okay, sometimes you can be mobile but not wireless, and sometimes you can be wireless and not mobile. So a lot of these two terms, mobile and wireless, are used together a lot of times, but they mean quite different things. So in terms of wireless systems can be classified as fixed wireless, where, for example, if you've got a wireless link between two buildings, that will be fixed wireless because both the transmitter and the receiver are fixed, they don't move. And in the case of a cellular communication where a user is moving, you have mobile wireless. Now, how popular are wireless technologies? Now, this is another slide that I picked up from a conference because I thought it was quite an interesting slide. It sort of shows how long it takes for a particular technology to penetrate into the market. So on the y-axis, you've got penetration from 0 to 100%. So as time goes on, more and more people start using a technology. And on the x-axis, you've got the years. Okay, how long does it take? Okay, so this is years since the invention, and here you have penetration in the market. So if you look at a technology like automobile that came out around 1886, it took almost more than 100 years, and it still hasn't reached 80% of the of the market. Whereas if a telephone penetrated the market much more faster, electricity even more faster, television much more faster. And if you look at the newer technologies that we have today, which are the mobiles and broadband access, you can see that these technologies are being absorbed into the market much more faster than the other important technologies that are associated with our day-to-day life. Okay, now I told you about these two terms before, mobile and wireless. Now, you could, as I said earlier, if you've got a stationary computer which is connected maybe via a wired network, it's neither wireless nor is it mobile because it's fixed, it cannot be moved. Maybe if you have a notebook in a hotel, which is connected maybe through a wired link, you may be able to move around with your notebook. So there is a certain amount of mobility associated with it, but it's not wireless. The third example that we have here is a situation where maybe you have a wireless link between two buildings, and here you have a wireless link, but there's no mobility associated with it. So, and the last example is an example where you have, say, somebody with a PDA walking around. So not only is the device mobile, but the link between the PDA and the network is a wireless link. Okay, so the term wireless and mobile mean quite different things. So you essentially you can have 4 possible situations, and this is what is given up at the top here. Okay, so you can either have mobile wireline, fixed wireless, mobile wireless, and fixed wireline. Okay, now in terms of mobility, there are different types of mobility that are defined in the text. Okay, there's a term called terminal mobility, personal mobility, service mobility, session mobility, and they mean quite different things. Okay, so when you're on a telephone line, say you're at home talking on your Telstra or Optus fixed line, there's no mobility associated with it. Okay, maybe if you have a deck terminal and you can move around, you have a certain amount of terminal mobility. Okay, so essentially terminal mobility involves the fact that your handset can move around. Personal mobility involves the fact that you as a person can move from maybe one terminal to another terminal. Maybe you can take the SIM card out of your current handset and put it into another terminal. Okay, so in that case you're using a completely different terminal, but as far as the network is concerned, it is contacting the same person. Service mobility occurs when maybe you move from one part of the world to another part of the world, and assuming that you've already arranged for roaming agreements, then some of the services that you have in your home network get moved over to the next network to which you're roaming onto. Okay, so that is service mobility. All the services that you are subscribed to in your home network are available in the network which you roam to. And the last type of mobility is called session mobility. Okay, so maybe you start a session on one network and you have now moved into an area where your current network is not there. Okay, but your wireless device, the device that you have, is smart enough that it detects another network to which it can connect to. Okay, and it connects to that network, and it's such that the session that you had in your previous network continues on in the new network. Okay, now in some cases these session mobilities have a certain amount of vertical handover, or you're being handed over from one network to another network in such a way that your existing session, maybe you start an FTP download in your first net. Say, imagine this particular tablet PC that I have has got a wireless LAN card as well as a 3G card. So maybe I start a download here, and as I walk out of building 1, or this is building 6, as I walk out of this building, it realizes that I'm no more inside the wireless LAN coverage of this building, but it can detect a 3G network, and because this device is built with a 3G card, it connects to the 3G network, and the same session that you started when you were in this network carries on in the next network. Now, session mobility is probably the hardest to implement in real life. Okay, now we've seen that terminal mobility, personal mobility, and service mobility are pretty much taken as granted in our lives today. But session mobility is something that needs a lot of work to be done before it can become a reality in the future. Okay, in terms of coverage, now one of the important things about wireless network is the idea of coverage. Okay, so you can have wireless networks that have a very small coverage area. For example, these networks that are referred to as personal area networks, networks that use Bluetooth and similar technologies, may have only a radius of about 10 meters. And then you may have, so their coverage area is very small, maybe a few steps from between the transmitter and the receiver. Then you could have local area networks like a Wi-Fi network, which could be of the order of 100 meters within a building, for example. Then you could have wide area networks. WiMAX is another technology that provides wide area networks of the order of 10 kilometers. Then you could even GSM, GPRS, all of those would come under the category of wide area networks. With a mobile telephone network with handover implemented in it, most operators in Australia now have mobile networks that cover most populated areas. So in this case, you have maybe hundreds of kilometers of coverage associated with a mobile telephone network. And then maybe the whole of Australia can be covered by a satellite network. So you can see that there are a number of different technologies here. Each technology has a specific coverage associated with it. Okay, and if you go beyond that coverage, you basically don't have a service. But then when you move out of the coverage area of one network, maybe you are inside the coverage area of another network which has a larger coverage area. Okay, and this concept, we'll talk about this towards the end of this lecture. It's a concept of overlay networks, where we have one wireless network being overlaid on top of another. Okay, and usually the smaller the coverage area, the higher the data rate that you can obtain from that network. And as you get networks with a larger and larger and larger coverage area, the data rates start decreasing. So, for example, in a GSM network, which has pretty much one of the largest coverage areas now, you can probably get the lowest data rates at present. Okay, so we move on to wireless applications. What sort of things are wireless networks used for? Well, before we look at that, the three main category of services that we look at are voice, data, and video. And each one of these services, most of the services are built on these three: voice, data, and video. And each one of these category of service has certain requirements in terms of delay. Okay, what is the maximum delay that a human eye or a human ear can cope with when listening to voice or when looking at a video? Okay, so in general, for human voice, it's of the order of 100 milliseconds. So if you start getting delays higher than 100 milliseconds when you are speaking to somebody, your ear cannot cope with that delay. Similarly, when you have packet losses, essentially we are moving to a stage where all information is going to be eventually transmitted in the form of packets on various networks. So when we start getting packet loss, greater than 1%, it becomes very difficult for the human, both the human ear as well as the human eye, to cope with that. In terms of bit error rate, when we start getting bit error rates larger than 10 to the minus 2, or basically 1 in 100 or 1 in 1,000 bits being in error, that starts becoming problematic. Okay, so these are the important requirements of the three, the voice, the data, and the video that we deal with in life. So each one of them has certain requirements in terms of delay, in terms of packet loss, in terms of bit error rate, and in terms of data rates that are associated with these various services. So if you look at this example here, you see that it gives you some ways that wireless networks can be used in the case of road traffic. Okay, so here we've got a situation where we've got a number of cars that are traveling on a road, and there are a number of wireless technologies that are around them. So you have a satellite network, and maybe some of the users are using the GPS in their cars, okay, getting signals from a satellite. You have maybe a number of cars like in this particular case here, these three cars here have formed an ad hoc network, and they are communicating with each other. Okay, there's also maybe practically along all the highways, most of the highways in Australia, you have base stations, and you're able to make calls, and you're able to download data and so forth. So maybe these base stations that are along the road, people are making calls using these base stations to call their friends and so forth. So you can see that just in the case of road traffic, a lot of wireless communication takes place when you are traveling on the road. Okay, here's another example, and this example demonstrates the concept of always best connected. This is possibly something that is a bit futuristic, but the technology that is needed to do this already exists at present. So here we have a situation where somebody is starting at home, and they're on their way to their work, and this is the sort of scenario that happens. So maybe you start a data session, maybe you've been working all night on a file for work, and you want to get that file to before you reach work, you want to make sure that your boss has that file. So while you're at home, maybe you are connected through a LAN, maybe a wireless LAN, and you're getting quite a good data rate associated with that wireless LAN, and you start a session. And this is again to do with session mobility that we talked about earlier. And as you move out of your home, your wireless LAN does not have coverage, because the coverage of wireless LAN is limited, maximum of the order of about 100 meters and ideal propagation. Then as you go outside your home, most likely if you live in a countryside, you only got a GSM or edge network, and you might have a much smaller data rate. And as you travel in your car, maybe you've only got a GSM network. And as you maybe when you get to a petrol station to fill up your petrol, maybe there's a wireless LAN in the service station, and your computer might be able to connect to the service station wireless LAN. You go and you park maybe you go to a railway station, you park your car there, get into a train. Maybe when you travel in the train, you might have access to either GSM or UMTS network with a slightly better data rate than when you are in the countryside. And as you get into the city, okay, now even in UMTS there are different types of cells. There are pico cells and larger cells. So as you get into a city, you start moving into a pico cell environment, and you get a much higher data rate. And as you travel through the city, maybe once you reach by train to Central Station, you might have to catch the tram to go to Pyramid or somewhere else like that. And while you're in the tram, you might be getting a much higher data rate because you're in the city, and then you reach in your office and you back to your wired network. So in this movement, which this process here might, for some people, it could be of the order of 1.5 hours a day. Okay, so during this 1.5 hours a day that they spend through this commuting to work, they could be going through a different wireless LAN, because we talked about the concept of overlaid networks, and you're always choosing if you had a very smart device, a device that is capable of communicating with many different radio access technologies, it'll always choose the technology that gives you the best data rate. Okay, now we've talked about the fact that your devices are portable, and in future wireless networks, what are important things that are taking place in wireless networks? Well, one of the things that is taking place is that we are moving into high and high frequency bands, because the lower frequency bands are getting congested. So as we move into high and higher frequency bands, we find out that CPUs are consuming more power, and essentially even the battery technology has advanced quite a bit because of mobile communication. I don't know if you remember when the first UMTS or 3G handsets came out, the batteries didn't last long. Okay, practically every day you had to recharge your battery, but over a period of time, the batteries have got better. Okay, so as we move into high and high technology, into high and high frequency bands, we find out that the devices that we are using are going to have consuming more power. Okay, there's also going to be the interfaces. The other thing that's also happening with most wireless devices is that they're getting smaller and smaller because most humans want to deal with as small a device as possible. Okay, so as devices get smaller and smaller, you find out that the interfaces, user interfaces, are also getting smaller. So it's a question of making sure that you can use your fingers comfortably on a wireless terminal. The other thing that is also happening in terms of the way, if you look at the way wireless devices have changed over the last 10 years or so, in future you will be moving towards more and more voice recognition and so forth, so that possibly in the future we might not even have a keyboard or set of numbers on a wireless device, because we'll be able to do everything using voice recognition. But again, when we start putting this voice recognition, we're going to have more computing resources that are needed in our wireless devices, and hence the amount of power consumption. Power consumption has become such an important issue that even when they're designing the next generation of wireless networks, essentially the 4G, currently the 3G is out there, the 4G systems that are coming in the next couple of years, even the design of those technologies are considering power aspects. Okay, how can we ensure that user devices can last longer before being recharged? Because if you come up with a technology where you've got a terminal that you have to charge every half an hour, that technology will not take off. Okay, so the battery power is also a very important aspect in the way wireless systems are moving. Okay, now in terms of wireless and wireless networks, maybe sometimes I'll ask you a question just to, you probably get tired of listening to me. So how do you compare wireless and wired networks in terms of the following? Say in terms of bit error rates, or in terms of transmission speeds, or in terms of delay. In terms of these factors, how would you rate wireless and wired networks? Say in terms of bit error rates, what can you say about bit error rates that can be achieved in a wireless network and a wired network?
10 Gbps in wired.
Sorry?
10 Gbps in wired.
No, I can't understand.
10 Gbps in wired.
Yeah.
And
No. What's bit error rates in terms of bit error rates? BER.
Wireless would have a larger bit error rate?
Yeah, definitely wireless systems have a much larger bit error rate. The probability that a bit is corrupted when transmitted across a wireless transmission medium is much higher than the probability that a bit is corrupted during transmission in a wired network. Okay, so again, we go back to that the slide that I had earlier, and you saw what are the type of bit error rates that are satisfactory for voice, for video, and for data. You see that we have to achieve those acceptable bit rates. Okay, so in order to achieve those, for example, I showed you this slide earlier. I said that for these services we have to achieve these bit error rates. Otherwise, we can't use. For example, if we don't achieve a bit error rate of 10 to the -7, which is like 1 in 10 million bits being corrupted for the human eye to be able to cope with video transmission, then we cannot use wireless video on wireless. Okay, so what we have to do then is, okay, we have to put extra error coding techniques in wireless networks, much more sophisticated error coding techniques in wireless networks compared to wired networks to achieve those kind of performance targets. Okay, so all of these have, so in general we have higher loss rates in wireless transmission because essentially information is being transmitted in a shared medium, and it's being affected by a lot of things, even things that are happening on the sun. Okay, whenever there is a sunspot, the radiation that is being generated by the sun affects wireless transmission on Earth. Okay, so a lot of phenomena affect wireless networks. The other aspect is the wireless medium is a very finite medium. Okay, we've only got a finite amount of frequencies that is available. So most governments control the way the frequencies are allocated. Okay, so there are some bands that are called license-free bands. So those bands, anybody can transmit on those bands, but most of the frequency bands are licensed bands. So that means you've got to get permission from a government authority before you can transmit on those frequencies. Now, so in terms of if you want to put a point-to-point wireless link between 2 points using in one of those frequency bands, which are licensed frequency band, you've got to go to the government and you've got to apply for permission to use that frequency band, and the government will check if that particular frequency band has been allocated to somebody, if your transmission is going to interfere with other signals being transmitted around that band, all of those things have to be checked. Whereas when you're setting up a wired link, you don't have to do that. Okay, you just get a piece of wire and link your transmitter and receiver, and nobody really cares, because you know that all of the energy is confined in that transmission medium. The third aspect is that because of the nature of wireless communication, the transmission rates that you achieve using a wireless transmission system is much lower than the transmission mediums that you can achieve with a wired network. Okay, for example, with GSM, the practical rate is about 9.6 kilobits per second. You also have higher delays and higher jitter with wireless transmission. Now, what is meant by the term jitter?
Varying delay.
Sorry?
It's a varying delay.
Variation of delay, okay? Now, delay, that is a very important point, because delay by itself is okay. For some extent, we can cope with delay. But when there is a variation of delay, okay, when the delay varies with time, or if the variation of the delay is not linear with frequency, okay, if it's a nonlinear function, it becomes far more difficult to design a wireless communication system in which you have a nonlinear jitter response. The other aspect about wireless communication is that it's because you're transmitting in the air, anybody who has the right equipment can listen to the signal. So whenever you transmit anything across the air, you try and encrypt it so that nobody can listen to it. Okay, now this is a slide, again, another slide that I picked up from Goldsmith's slides. This is a very important slide because it shows that as a function of time, as we moved in radio from first generation wireless LAN to second generation wireless LAN and so forth, in terms of local area networks, there's always been a big gap. Okay, there's always this big gap between wired network and wired. So the data rates that you can achieve with wired networks is far higher than the data rates that you can get with wireless network. It could be both for local area networks as well as for wide area networks. You see that there is a large gap, and this gap is actually increasing because wireless networks are trying to catch up all the time with wired networks, but the wired networks are progressing at to much higher and higher data rates. Okay, hopefully when wireless networks also become optical, then possibly that might be the time when the two data rates could sort of merge. But for the time being, there is a large gap between wired networks and wireless networks. Okay, so you can see that if you look at the popular networks today, GSM, high-speed circuit switch data, GPRS, Edge, UMTS, although in theoretically, if you look at marketing material, you'll find these kind of data rates being quoted. Okay, but in realistically, the data rates that you can get are much smaller. For example, with GSM, the maximum, the more realistic data rate is around 9.6 kilobits per second. And with HSCSC, what you're doing with high-speed circuit switch data is getting a number of time slots. So maybe in this particular case, you're getting 4 time slots to use for yourself. And so the data rate that you're getting is approximately 4 times what you're getting with maybe with 1 time slot. And even with UMTS, although the maximum is supposed to be 2 megabits per second, the realistic data rate that is being achieved is of the order of 100 kilobits per second, unless you obviously are very close to the base station and there's very little other interference from other users. Okay, in terms of okay, let's just how's everybody still there, still awake or falling fast asleep? Okay, let's just take a 5-minute break so you can go and get something to drink and come back.